Let's take a look at this problem. Here we have a rectangle. The length of the shorter side is 1. There are 5 circles inside the rectangle. These circles either touch the rectangle or touch the other circles. The 2 circles at the side are identical, and in the middle, the top circle and the circle at the bottom are also identical. Find the length of the longer side of the rectangle. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. The key to solve this problem is to use the property of tangents of circles. So if I label the centers of circles as well as the tangent points, I'm just referring to those between circles, but not those with the rectangle. So the centers and the tangent points should be collinear. As in, if I try to draw a line between the 2 green dots and the red dot in the middle, they should pass through the same straight line. And same for this. Even as we keep going down. And the same for this dotted line. Of course, we can also do that for the one in the middle. So now we actually have an isosceles triangle. The reason is this. For the big circle at the left, the radius is actually computable. It's actually 1/2. The reason is that the shorter length of the rectangle is exactly the same as the diameter. So it's 1/2. And so we have 1/2 for the parts between the green dot at the left and the 3 red dots as the tangent points. Then we have 2 circles in the middle. 2 types of circles in the middle. I'm going to let big R to be the radius of the larger circle, which are these. And small r, let me use red perhaps, small r as the radius of the smaller circle. I've labeled them. Now we have an isosceles triangle because these sides of the triangle have lengths 1/2 plus big R. And since the green dot at the middle is the midpoint of the base of the isosceles triangle, that means we have a right angle in the middle. We have a right angle here. So then from this, I'm going to use the Pythagoras theorem, which tells us that 1/2 plus small r all squared plus 1/2, sorry, not 1/2, but the other leg of the right triangle, small r plus big R all squared. Maybe I can even use red color for the small r so you can see that more clearly. And that equals to the hypotenuse squared, which is 1/2 plus big R all squared, the one I highlighted in blue. So now from this we can expand. For the first squared, we have 1/4 plus small r plus r squared. And for the second squared, we have small r squared plus 2 small r big R plus big R squared. And the sum of them is equal to 1/4 plus big R plus big R squared. Now from this we can cancel out some terms. The first is 1/4, you can take that out, and R squared as well. And simplifying, we will have 2 small r squared plus small r plus 2 small r big R equals to big R. So that's our first equation between big R and small r. We can actually establish a second equation related to big R and small r. I can look at the line in the middle which passes through the three small circles, and the segment has length 1 because it's just the same as the shorter side of the rectangle. Going through this blue line, we have actually passed through the diameter of the large circle twice and the diameter of the smaller circle. So that means the second equation is twice the diameter of the larger circle plus the diameter of the small circle is equal to 1. Now that means 4r plus 4 big R plus 2 small r equals to 1. So some other relations between big R and small r are two unknowns in this problem. On the other hand, we can look at the big picture and try to relate our goal the length of the longest of the rectangle with the unknowns we have used at the beginning. In fact, we can make use of this orange line. This is exactly the same as the length of the longest of the rectangle. And from this, we have gone through the diameter of the largest circle at the two sides twice. So that is question mark equals 2 times 1 plus 2 small r. So actually, for our final goal, we're supposed to find small r. Now that means we should aim for solving for small r from our two equations about small r and big R. So let's try to solve it. So from the second equation, big R is equal to 1 minus 2R over 4. So that's equation 3. And I'm going to put this into the first equation. The first two terms remain the same, while for the other term, I'm going to replace big R by 1 minus 2 small r over 4. So then 2r squared plus r minus 2r squared over 2 equals 1 minus 2r over 4. Now, let me group the terms together. Square terms together, r terms together, and then minus a quarter at the end. So for r squared, we have 2 minus 1, so the coefficient is 1. As for the r term, the coefficient is 2. So 2r minus a quarter equals 0. So it's a quadratic, and we can try to solve it with the quadratic formula. 2 squared plus 4 times 1 plus times a quarter over 2. So it's minus 2 plus or minus root 5 over 2. Of course, we can reject the minus case because a radius is supposed to be positive. So that means r is supposed to be equal to minus 2 plus root 5 over 2. And from this, we can say that our final answer is as explained above, 2 plus 2 times this number. So it's 2 plus minus 2 plus root 5. And so root 5 is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.